it again. So welding. Hello. Hello. Can I start?
Yes, sir.
Yes, sir.
Okay. Okay. So as I was saying, fusion welding on the basis of using filler materials can be classified into three separate categories. So the welding process where you will find that there is no application of filler materials, like what you have done in your lab. I think all of you have done the welding experiment in your college, in your workshop. I assume all of you have gone through this experiment. So the experiment which we do is nothing but an example of autogeneous welding. In that case, we don't use filler materials. As we go on in the higher standards, that means from first year to second year, we will see that we will be using filler materials. Okay. In case of second year, we generally use, we generally tend to use the filler materials and do the homogeneous welding. Okay. So autogeneous welding means there will be no application of filler material. No filler material would be added to the base material. Okay. So this is the basic thing. Now, in case of, so what are the examples of autogeneous welding? The solid state welding, like friction welding, like forge welding, the friction star welding. We had seen it in the previous day. So these are the examples of autogeneous welding. So all solid state welding processes would be autogeneous welding. That means there is no case of adding adding filler metal filler metals into it. In case of some fusion welding processes like manual metal arc welding, gas metal arc welding, TIG. TIG means tungsten inert gas welding. In this in these types of welding processes, you will see it can be done using or following the autogeneous process. Okay, that means there is no need to add the filler materials. Now let us
হ্যালো
come
স্যার।
on to the hello.
হ্যাঁ হ্যাঁ স্যার, বলছি এই অটোজেনিয়াস ওয়েল্ডিং এর মধ্যে কি ওই ফ্রিকশন স্টার ওয়েল্ডিংটাও পড়বে? কারণ ওখানে তো কোনো ফিলার মেটেরিয়াল ইউজ করা হয় না।
Yes. Obviously, যে কোনো solid state welding, any solid state welding process would be autogeneous welding.
ওকে স্যার, ওকে স্যার।
Okay. So what is homogeneous welding? Now I have already told you that in case of welding there will be a base material and this filler material would be added separately. So if the chemical composition, if the base material and the filler material they are same from the perspective of chemical composition, then it will be an example of homogeneous welding. Okay. So it doesn't mean it is a separate category like GMAW, TIG, or SMAW. That means shielded metal arc welding. So there are some specific abbreviations. So I'll be using these abbreviations like MAW, metal arc welding, MMAW, manual metal arc welding, GMAW, gas metal arc welding, MIG, metal inert gas welding, TIG, tungsten inert gas welding. So from now onwards, I would use the abbreviations so that you can understand. Okay. So these are the different welding categories. So homogeneous welding means the base material and the filler material would have same chemical compositions. Okay, is that clear? Hello.
আরেকবার একটু রিপিট করবেন হোমোজেনিয়াসটা?
Sure. Suppose we are trying to weld aluminium materials. Two aluminium materials we need to weld by a certain fusion welding process. Then we are using a filler material which is also aluminium. We are using the filler material as aluminium. That means if the base material and the filler material is same, then we can use the homogeneous welding process. Ek minute. Just a minute. Okay. So is that clear now? Homogeneous welding?
Yes, sir.
Okay. So heterogeneous welding is exactly opposite to homogeneous welding. That means if the base material and the filler material doesn't have the same chemical composition, then it would be heterogeneous welding. So TIG welding, like tungsten inert gas welding, can be done homogeneously or it can be done heterogeneously. Okay, so any welding process, any fusion welding process can be done in both the ways. So depending on our requirements, depending on the specific character characteristics which we require, which ourselves মানে আমরা যেটা চাই, depending on the requirement, we we choose the way of welding. It can be homogeneous, heterogeneous, or autogeneous, depending on the specific requirement it has to serve. Okay, so now let us see the weld joint configurations. Okay, so these are the configurations which are generally produced by welding. Okay, so butt joint, corner joint, lap joint, T joint, edge joint. So these are the general welding joints which can be performed, which can be developed by using the various welding processes. Okay, nowadays overhead welding and underwater welding is also done. Okay, I would also like to see I would also like to show you the underwater welding process through a video in the later on in the later days of this training. But so welding has been upgraded nowadays, and various shapes, various complex designs can be performed by using this welding process. Okay, so overhead welding, underwater welding, ultrasonic welding. So these are the very important modifications that have been done during this 28th century, and these are creating a lot of news. Okay, so I will show you the videos of overhead welding and underwater welding, which was seeming impossible in the previous years, has been made possible now. Okay, now with this, let us, so our lecture session, our training session would be defined in this way. So first we will discuss the principles of solid state welding. Then in the next two classes we will see two different solid state welding processes. Okay, in the next two class we will discuss about friction stir welding and ultrasonic welding, and in the next two class we will discuss about the fusion welding, and we will start discussing about electron beam welding and laser beam welding. Okay, so to start with, we need to understand what are the uh, principles of solid state welding and what solid state welding actually is. Okay, so I have already told you that solid state welding means the base metals would not be melted. Okay, there will be some internal changes, there will be some internally rise in temperature causing the joining. Okay, so as you can see here, we can see an example of friction welding. Okay, so you can see an non-rotational chuck and a rotational chuck. Okay, so you can also assume or think this non as a non-rotating body and a rotating body. So you can see that a body is fixed and the other cylindrical body is rotating. Okay, now what happens, these two bodies, they are moved axially. Okay, now these two parts are brought together in contact, and when they are in contact, because of the because one part is rotating, obviously friction would would be created, and because of this friction, high thermal energy would be generated. Okay, and because of this thermal energy, what will happen, the
mating parts or the joining parts would be deformed, and because of this deformation, what will happen? If we apply some amount of pressure, if you apply some amount of pressure from both the sides, then obviously after some time these two materials would be joined. So this is the principle of friction welding. Friction welding is also an example of solid state welding. So let us see how do we define this solid state welding process. So solid state welding is a welding process in which two work pieces are joined together under a pressure, providing an intimate contact between them and a temperature essentially below the melting point of the parent material. Bonding of the materials is a result of diffusion of the interface atoms. Okay, so what are the important factors you must address? First of all, in case of solid state welding, a pressure is absolutely necessary. So you cannot accomplish any solid state weld joints without pressure. Okay, in case of solid state welding, when you are dealing with solid state welding process, pressure is extremely necessary. And what is the second point which needs to be noted? The second point is that the temperature is essentially below the melting point of the parent material or the base material. Okay, so from the perspective of pressure and temperature, you need to understand
the uniqueness of solid state welding. Pressure is absolutely mandatory. Pressure is absolutely necessary in case of solid state welding, and the temperature is always less than that of the melting point. Okay, now according to AWS means American Welding Society. According to AWS, a group of welding processes which produces coalescence at temperatures essentially below the melting point of the base materials being joined without the addition of a brazing filler material. Pressure may or may not be used. Okay, now in that case, they are also taking the cases of brazing and soldering into this category. Okay, now in this case, you can say pressure is absolutely mandatory. Okay, in case of solid state welding, pressure is very required, very important. Okay, but according to AWS, they have considered that pressure may not be used. So this is very rare. This is very rare that you will find that pressure is not used in solid state welding process. Okay, so this case can be done for welding such as in such processes where the material has very low strength. Okay, where pressure may not be required. But I don't have any information about any welding process, about any solid state welding process where pressure is not used. Okay, so I would like to give you as a home task or as a duty. So if you can possibly search in the internet where in case of solid state welding where pressure is not used. Okay, is that clear? Hello? Hello?
Yes, sir.
Okay, so it is your task. Okay, I will ask this question in the next day.
Okay, so now let us discuss the principle of solid state welding. That means how solid state weldings are created. Okay, so how solid state welding are being created. Just a minute. Okay, so what is the principle of solid state welding? So before that, before starting discussing starting the discussion on the principles, starting the discussions on principle, we like to discuss about the quality of the
quality of the weld joint which is produced through friction stir welding process. I'm sorry, through solid state welding process. Now, it is obvious that the solid state welding processes is always carried out at a temperature which is less than that of the melting point, right? So melting is out of question. Okay. Now, if two materials are being joined, then what happens? There is a case of atomic bonding. Okay, so two materials are being joined by the mode of by using the process welding, and welding essentially means that there is some atomic bonding being created or generated. So this, if you see the forces which are involved in case of atomic bonding, they are way higher than that of the strength which the base metal possess. Okay, so আমি কি বলতে চাইছি, is that clear? Suppose these two base metals are being joined. Okay, so these two base metals are being joined by welding. Now in this zone, what is happening? There is a case of atomic bonding. Okay, now this atomic bonding means this atomic bonding will have high strength. Okay, so this is atomic bonding. Okay, now let us consider this atomic bonding is, this has X amount of strength, and this base metal has a strength of Y. So this X, the strength of this atomic bonding is much higher than this Y, than the strength of the base metal. So if we are creating a weld joint, then there is no need of creating a joint which would give us this amount of strength, because we are only bothered about this Y amount of strength. Okay, we don't need the strength of this atomic bonding, we only need the strength of this base metal. Okay, because our all applications would depend on the strength of this base metal, it will not depend on the strength of this atomic bonding. Okay, so if we are able to create a joint strength which is very close to Y, joint strength. Okay, if the joint strength is very close to Y, or this is the strength of base metal, okay, base metal strength, then we'll be pretty happy about the strength of the joint which have been which has been achieved by the welding process. Okay, so to analyze this, we can see that in case of ductile materials, what happens? The material fails where the interatomic force is weakest. Okay, in case of brittle materials, what happens? The failure takes place by the extension of cracks which are already present within the system. Okay, so this is the important word which you need to address. Bulk strength, that means the whole strength of a material is much lower than the bonding forces of the constituent atom. So this bulk strength which I was talking, which I have referred as Y, and the bonding forces is being referred by X. So this bulk strength of a material is much lower than the bonding forces of the constituent atom. So a good welding doesn't require to achieve a strength equal to that between the adjacent lattices. Okay, that means it is X, and if this X, so it doesn't mean that Y has to be equal to X or very close to X. It is enough if Y attains the strength of base material. Okay, if the strength of Y is equal to base material, then it is enough. Now, because in case of welding, atomic bonding is involved, because welding creates a joint by the virtue of atomic bonding, sometimes you will find that the joint strength would be greater than the base material. Sometimes you can find that the joint strength has become much more compared to the base material. In that case, we define a term joint efficiency. Joint efficiency. Just a minute, I will clear this. So joint efficiency joint efficiency. Okay, so let us say uh, sigma joint minus sigma base metal by sigma base metal. Okay, into you can also multiply by the 100%. Okay, so depending on the efficiency of joint, this this sign can be modified. If the base material has higher strength compared to this joint, then this will be shifted in this way. Okay, clear?
Have you any
Yes,
questions
sir.
regarding this?
No, sir.
Okay, okay. Now let us move on to the principle. Okay, so let us see the principles by which this solid-state welding is being achieved. So the fact is that a good welding doesn't require to achieve a strength which is equal to that between the adjacent lattices. Okay, that means the atomic bonding, the strength of atomic bonding is way higher than the good welding. I'm sorry, the strength of the atomic bonding is way higher than the welded joint. Okay, but there is no problem with that. We are very satisfied if the weld joints achieves a strength which is equal or greater than or something some amount less than the base material. Okay, we will be very satisfied with that. Okay, now in this case what happens? The metallic bridging. So when two materials are made to come into contact, what happens? A metallic bridging occurs. Okay, that means the you can if you remember your basic atomic concepts, then the outermost orbital electrons are being shared by two materials when they are in contact. So when they are brought into close contact, the outermost electrons, they are shared uh, by both of these two materials. Now in this case what happens? A phenomena called as metallic bridging. That means two metal are bridged by some electron sharing mode. So metallic bridging formation occurs through the small areas of asperities. Asperities means where there are some defects, where there are some adsorbent materials. Okay, through the small areas of asperities in the presence of adsorbed layers. Now, as I have already told you that pressure is absolutely required. It is very much necessary for solid state welding. The flow pressure which is being applied makes the mating areas to come into contact. So that means you are applying pressure to make the two materials come into very close contact. Okay, so where the weld is formed, and now what happens if you suppose you are applying pressure like this and you are applying pressure like this. Okay, and after some time what happens here and
welded joint has been produced. Okay. So here this welded joint has been produced. Okay. Now the contact area is dependent on this flow pressure. Okay. The contact area is dependent on this flow pressure. Now what is this flow pressure? This flow pressure is nothing but the yield strength. The yield strength of the material. What is yield strength? Can anyone tell what is yield strength? Tanmoy sir has told you many times. What is yield strength? Can anyone say what is yield strength? Hello? Is there anyone who can say what is yield strength? What do you mean by yield strength? Do you remember what do you mean by yield strength? So this is the stress strain curve, right? So here, so this is the stress strain curve. So this would be a proportional thing, and then there is a curvy thing. Okay. So at this point, it is called as the yield point. That means this is the point where the first deformation occurs. Okay, for ductile materials, yield strength is taken as the strength by which we design different applications. Okay, suppose in a design sector we are going to use a ductile material, then in that case we will design this application on the basis of this yield strength of this ductile material. So this yield strength is sometimes also called as flow pressure. So this flow pressure and the yield strength, they are actually the same thing. So when we are applying the force, the pressure, okay, that means this material would uh, what will happen to this material? This material will start to internally resist. That means you are applying some external force. So the material will start to resist, and this will be the nature of the stress strain curve if this material is a ductile one. So the pressure, the flow pressure applied, okay, makes the mating areas to come into contact. So this means these areas, they are coming into contact. These areas, they are coming into contact. Okay. Now, what will be the area of contact? What will be the area of contact? Suppose this is your area of contact. Suppose this is your area of contact. So how you can calculate this area of contact? This area of contact can be calculated very easily. This area of contact can be calculated very easily. Can you tell me what is the basic formula of stress?
So stress is force per unit area.
Force per unit area. So force per unit area would be the yield strength of the flow pressure which we are talking about. So if you know the force which is being applied, so Fa is the force applied and sigma y is the yield strength of this specific material, then what will be a area of contact? It will be very easy. The force which is being applied divided by the yield strength of the material. Okay. Thus, this area of contact can be calculated. Okay. Clear?
Yes, sir.
ইয়েস স্যার, বুঝে গেছে।
Okay, so let us move on to the next slide.
So now we would discuss the important factors which are very much required in case of solid state welding. So to assess the performance of solid state welded joints, we need to study these important factors. And what are the applications, what are the influences of these important factors, we must understand. In this discussion, we will also understand what are the greatest hurdles in case of welding. So suppose you are trying to weld two materials, then what are the challenges that you must face? Okay, we'll be discussing that. So before that, so let us, we will start with the discussions on surface films. Now, what do you mean by surface films?
That means if this is our surface, then let us consider this is a layer. Okay, there is some amount of layer of external materials. Okay, now this material, or generally we'll find the materials which we use as the base material to weld something, they are very much prone, they are very much sensitive to react with oxygen. So air is everywhere and oxygen is also everywhere. So what happens? Oxide layers form. Okay, oxide layers form. Now why these oxide layers are formed? Because of the reaction between the base material and the air at which it is exposed. Now you cannot avoid air and you cannot avoid oxygen. So that means you cannot avoid these oxide layers. Okay, so these oxide layers, they are the greatest hurdle to do any welding. So welding এর সবচেয়ে বড় শত্রু, the worst enemy of welding is this oxide layers, and you cannot avoid that. In case of any welding, you cannot avoid the oxide layers. Now what is the problem of these oxide layers? These oxide layers has a temperature near about 200 degree, I'm sorry, 2000 degrees Celsius. Their melting point, okay, their melting point is near about 20,000 degrees Celsius. Sorry, again I have spoken a wrong word here. So it is, these oxide layers have a melting point greater than 2000 degrees Celsius. Okay, now when you are going to fuse the material, okay, when you are trying to join these materials by using the fusion welding, then you are going to apply this amount of heat so that these oxide layers get melted. Okay, now as we go on providing the heat, so that means in case of, what is the source of heat in case of welding? If we are discussing the concept of fusion welding, so in case of fusion welding, electric arc or electrical energy is the source of heating, right? Hello.
Yes, sir.
So let us see that this is a very important thing. I mean, any student of automobile or mechanical should understand this, because this is the basic and the fundamental thing. Okay, oxide layers are the greatest hurdle to do any kind of welding. So in case of fusion welding, electrical energy or electricity or I, okay, this I or the electricity is the source of heating. So when there are some oxide layers distributed over the surface, that means this I is getting increased. The amount of current which needs to be supplied, which needs to be transmitted, that amount is getting increased. That means more and more power consumption. That means more and more less, what I can say, more power consumption means less profit. That means your cost, your total cost of welding is getting increased. Okay, so these oxide layers, what we do in case of welding, by in case of fusion welding, we generally do a preheating kind of thing. In case of fusion welding, we do a preheating kind of thing. That means before the initiation of the welding process, before the welding process starts, what do? We preheat the material so that these oxide layers can be, they can be melted. Okay, now what happens in case of solid state welding? This cannot be done. In case of solid state welding, there is no provision of heating. So what happens? Generally, there are some way outs which are being adopted, like in case of cold welding. In case of cold welding, what happens? In case of cold welding, there is a general method of scratching the surface. Okay, in case of scratching or brushing the surface so that these oxide layers can be removed. Sometimes with oxide layers, you can also see that there are some liquid films attached to this surface. Okay, with these oxide layers, liquid films are also attached to the surface. So this also needs to be removed from the surface so that welding can be done easily. But moreover, you must understand, you must be focusing on this point. So you must understand this oxide layer. They are the greatest hurdle of performing any kind of welding. Okay, so now let us move on to this fact. So when there is an application of temperature, when we are using the heat, okay, in case of solid state welding, there is also application of heat. The temperature may not be greater than the melting point, but there is some amount of temperature rise. So the temperature is generally 80 to 90% of the melting point. 80 to 90% of the melting point. So this is a comparatively very high temperature. Okay, so because of this high temperature, what happens? The surface generally deforms. Okay, this surface generally deforms. Now in case of welding, there is very little chance to calculate the specific deformation. Generally we use bulk deformation. Okay, bulk deformation means, suppose a material had a thickness of Ti. So Tf minus Ti is a change in thickness after the welding. So if you want to calculate the percentage deformation, then you can do this. You can adapt this formula. You can do, and you will be able to calculate the deformation. Okay, so in case of a certain amount of deformation is absolutely necessary. If there is no deformation, then there is no welding. If the surfaces which are to be joined, if the base metals which are going to be joined, if they are not deformed, then there is no chance of welding. 10% deformation is absolutely necessary. Okay, so 10% deformation is absolutely necessary. There is a term which we call as critical deformation. That means this amount of deformation should be and must be happening so that the joints can obtain a higher strength. So there is an important factor called as critical deformation. Okay, then we move on to the recrystallization and diffusion factors. So recrystallization means, creating new grains. Recrystallization.
So any metal or any material is a collection of crystals. And what do you mean by crystals? Crystal means the lowest unit of a material. So for any material, you will see, if you go on breaking the materials, you will see a structure, a cube. Okay, a cube. These cubical structures can be various, can be separate uh, depending on the categories. It can be BCC, it can be BCC, it can be FCP, sorry, FCC, and the other one can be ACP. So BCC means body centered cubic. That means at the center of the body there will be an atom. Okay, so these are the unit cells of a atom. Okay, that means if new crystals are being formed, if new crystals are being generated because of this welding, then recrystallization can start. And in case of solid state welding, recrystallization happens. Okay, and since recrystallization happens, the material does not lose its ductile properties. Okay, so the ductileness or the ductility of the materials remain intact, and the joints which are being produced by the solid state welding, they give us a higher quality. Okay, and then we move on to this diffusion part. Diffusion means it is an important phenomena, and in case of diffusion, what happens? The atoms, the molecules are diffused together. Okay, so there, you know the principle of diffusion. I am not getting into that. So in case of diffusion, because of this diffusion, the joints which are produced by solid state welding, they are of high category or high strength. Okay, so with this we'll end this here. And these are the examples of solid state welding process. Here you can see the forge welding, and this is the friction welding again for you. So forge welding basically means heating the temperatures up to an elevated temperature. You will heat up the body at up to an elevated temperature and go on hammering to join these two materials. And I have already discussed the principle of friction welding. So now you can see the two examples. The upper one is the example of friction stir welding, and the lower one is an example of ultrasonic welding. So this ultrasonic welding is a very interesting thing. Here you can see the green cables are being joined because of the ultrasonic vibrations that are being created. Okay, so we'll discuss these concepts. Okay, in the next classes, in the next two classes, we'll start with friction stir welding, and later on we'll discuss about the ultrasonic welding. So do you have any questions?
Sir, I have one question.
Yeah, sure.
Hello, sir.
Here, ask.
Sir, what did you told about that picture which was above the ultrasonic welding? What kind of welding was that?
So this one is
Yeah.
friction stir welding.
Friction stir welding. Okay.
Okay. Anyone, any questions? Second year automobile, do you have any questions? Sojit and Jibitesh, do you have any questions?
No,
Probably
sir.
you haven't heard about welding and these principles, so this is a little bit tough for you to understand. I can understand these things, but do you have any questions? Hello, Shojit and Jibitesh. Shojit, do you have any questions, or Jibitesh, do you have any questions?
No, sir, no.
So, are you able to understand what I had said, or there are
Yes,
some
sir.
problems?
No, no, sir, I don't have any problem.
Okay, okay then. So I will share this PPT, and I will also share some notes, so that if you go by yourself, you can understand it in a better way. So I will provide the documents so that you can go on with your understanding. Okay. Okay. Anyone having any other questions?
Sir,
So the
sir,
oh, sure. Devjyoti
s-
ask.
sir, where can we see the application of this ultrasonic welding?
Ultrasonic welding is basically used in case of welding the materials which have very less thickness. Like in case of welding the cable materials. Okay, where you are supposed to join materials or wires with very small thickness. You can use this ultrasonic welding.
Okay. And sir,
Okay.
friction stir welding?
Friction stir welding has a high application in the automotive areas, in the transportation areas, in case of different parts of naval ship, different parts of aeroplane, different parts of automotive body and chassis nowadays are now being created by friction stir welding. So in most of the transportation areas, you will find the applications of friction stir welding. That wherever aluminium is welded, if you find that aluminium is welded in any case, you will find friction stir welding as the only option.
Okay, sir, thank you.
Okay. Any other questions? Or shall we end this? Okay, so I will close this session. See you on 4 p.m. Okay, we will start discussing about the energy transfer concepts in case of automotive engines. Okay, so see you at 4 p.m.
না না, কালকে হবে না অ্যাকচুয়ালি।